Elementary statistics, practice test number 4, covering chapters 8 and 9. Here's chapter 9, inferences from 2 samples.
Among 843 smoking employees of hospitals with the smoking ban, 56 quit smoking 1 year after the ban. Among 703 smoking employees from workplaces without the smoking ban, 27 quit smoking a year after the ban. Is there a significant difference between the two proportions? Use a 0.01 significance level. Construct the 99% confidence interval for the difference between the two proportions.
We are dealing with a binomial distribution because you either quit smoking or you don't. There are 2 outcomes. In the first case, n sub 1, let's go with the first case being n sub 1 here, 843. X sub 1 is 56. Second case, n sub 2 is 703, x sub 2 is 27. We've decided to go with the alpha of 0.01. So a couple of things. P bar is x sub 1 plus x sub 2 over n sub 1 plus n sub 2. And we need that for the z, which is p1 hat minus p2 hat over the square root of p bar q bar over n1 plus p bar q bar over n sub 2. Needless to say, you have this formula in the formula sheet. So a couple of things we need to do before we move on. Let's calculate the p1 hat, which is x sub 1 over n sub 1, just like p hat, which was x over n. The p2 hat would be x sub 2 over n sub 2. Let us calculate p bar, x sub 1 plus x sub 2 over n sub 1 plus n sub 2. We plug in again. Look at the given. All you have to do, plug in. Again, could be done by technology, but it's important to see how we arrive at it in case. So having said that, what is the first step? H0. P1 minus P2 is 0. H1, P1 minus P2 is not 0, which makes it a two-tailed test, and that's a claim. And by the way, 0.01 significance level for a two-tailed test corresponds to 99% confidence interval. If it were one-tailed test, that means either right-tailed test or left-tailed test, then 0.01, after multiplied by 2 and subtracted from 1, will be equivalent to 98% confidence interval. So again, it's a two-tailed test. Alpha of 0.01 corresponds to 1 minus alpha, or 99% confidence interval. By the way, you can write P1 equals P2, in which case you're going to write here P1 is not equal to P2. All you have to do, just pay attention and be consistent. We're going to calculate the Z for test statistic. That's why we did all these calculations, so we can plug in. As you can see in this formula, we need all of those. Plug in, results in the following. The next step is the critical value. Choice of alpha, two-tailed test, Z becomes plus minus 2.575. And so in a matter of comparison, the test statistic is in between. So it's a non-rejection region. So therefore, fail to reject the null hypothesis. So we're going to stick with the first part of the decision. The rest comes from the first step. So fail to reject the null hypothesis. Let's go here. If we are not rejecting H0, we are rejecting H1. We are rejecting the claim becomes false. There is not a significant difference between the two proportions. You can do the writing anyhow you want. If we were to do the technology, we would use two proportion z-test. And we would plug in x sub 1, n sub 1, x sub 2, n sub 2, and we make a decision as to which one left-tailed test, right-tailed test, two-tailed test. We do the math, and it results in the following. So pay attention to what we have here. This is the test statistic. Again, of course, a lot more decimals when we compare it to ours. P1 hat, P2 hat, P bar, and this one which says P is the P value. And as you can see, 0.01, let's say 5, is larger than alpha of 0.01, which results in the same thing. So the P value is here. Now, we continue with the question. We want to find the 99% confidence interval. The formula is very straightforward. P1 hat minus P2 hat plus minus E. So all you have to do, calculate the E and subtract it from this difference and also add to that. So here's the formula. E is Z alpha over 2 square root of P1 hat Q1 hat over N1 plus P2 hat Q2 hat over N2. If you recall, we used P bar and Q bar when we calculated the test statistic, the formula from the previous page. And that's why sometimes the result may be slightly different. Otherwise, they would be identical. So you plug in, you do the calculation, and this number comes from the Z value that you got for the critical value of the previous page. You do the math, and you end up with E being this number. So this takes a little bit of time to calculate. Now, P1 hat minus P2 hat, it's pretty straightforward. We have them here. Subtract this number from it, add to it. So P1 hat minus P2 hat becomes this. You're going to subtract this number from this and add to it. It results in the following. So we're going through the process. So the result will be between a negative value and a positive value. Extremely small, negative point, we have 3 zeros and then 878, 0.056922. We get to the same result because this confidence interval contains 0. There is not a significant difference between the two proportions. In other words, fail to reject the null hypothesis. This is extremely important. Pay attention to the sign. This means 0 is in between. That means we go with H0. H0 is okay and acceptable according to this confidence interval. Now, confidence interval, two proportions, we do the math. It will result in this, and you remember that E minus 4, that means times 10 to the power of negative 4. If you write this, you see it's extremely close to what we have here. Needless to say, they use more decimals. They might be slightly different. So according to this, we are 99% confident that the difference in proportion is between the two values.
Company A claims that its yogurt cups contain, on average, fewer calories than that of a competitor. A sample of 50 such yogurt cups of Company A produced an average of 141 calories per cup, with a standard deviation of 5.4 calories. A sample of 40 yogurt cups of a rival company B produced an average of 144 calories per cup, with a standard deviation of 6.3 calories.
Let's make up this table that makes life easier. So we are going to go with Company A as the first group, N sub 1, X1 bar, S sub 1. Same thing for Company B, we're going to go with subscript 2. N sub 2 is 40, X sub 2 bar 144 calories, and S sub 2 is 6.3 calories. So let's write the given. Starting with the test of hypothesis, H0 mu1 is mu2, and H1 mu1 is less than mu2, making it the claim and the left tail test. We are going to use this formula to do the test statistic to calculate that. We just plug in the values. By the way, sometimes you see minus after this x1 bar minus x2 bar, you see minus and the parenthesis mu sub 1 minus mu sub 2, which comes from the H0, and it's always 0. By the way, you could write mu sub 1 minus mu sub 2 is 0. If you wrote that, you would want to write mu sub 1 minus mu sub 2 less than 0. So be consistent. It results in the following. So this is the test statistic. As far as the critical value, and it really depends on the text, I want you to pay attention to what I'm going to tell you. The degrees of freedom is the smaller of the two degrees of freedom, N1 minus 1 and N2 minus 1. And in this case, this is 49, this is 39, the smaller is 39, we choose 39, and T becomes negative 2.426. This is one way of approaching that, whereas technology doesn't do it this way. Technology actually calculates it. So let's pay attention to both cases. In this case, if we plug in the values, the critical value is negative 2.426. The test statistic is way into the non-rejection region. Therefore, fail to reject or do not reject H0. After that, we go back to step 1. If we are not rejecting H0, we are rejecting H1, the claim becomes false. There's not enough evidence to support the claim that company A's yogurt cups contain on average less calories than that of its competitor. However, if you want to do this by technology, TI calculator, you put 2 sample t-test and you either pull or not. In this case, we are not assuming equal variances. Normally out there, we're going to stick with this. We are not going to use the Z distribution. We are not going to assume equal variances. So that's normally the case for independent cases. We plug in and pay attention that this is no. So we plug in the information, no. When we do the math, notice what happens here. The result is different because degrees of freedom is calculated. How is that calculated? It's a pretty complicated formula. Normally, nobody expects you to do this by hand. The formula is A plus B quantity squared over A squared over N minus 1 plus B squared over N2 minus 1, where A is S1 squared over N1 and B is S2 squared over N2. Nobody expects you to use that formula. If you want to do that, the technology will do that for you. And because the degrees of freedom is different, so is the result. Nowadays, many texts go with that, including my open math. I want everybody to pay attention to that. But I want you to be exposed to both cases. Now we're going to continue with that thoughts, and we're going to go with the second part of the question. So this is a left tail test. So the area to the left of test statistic is what makes up the p-value. We don't have that number in the table. If you were to use the table, it's in between, and therefore area in one tail is also in between. So pay attention to the way we do that. We are looking for this number. Of course, the table goes with the positive value. This number doesn't exist, but with the proper degrees of freedom, which is 39. But it is between these two numbers, so the area is also between these two numbers, 0.01 and 0.025. And no matter what, it makes it larger than alpha 0.01. You will come up with the same result using the table. You will come up with the same result using the technology. In other words, technology gives you its own result. It may be different, but the p-value or the critical value gives you the same result using technology. And if you do it by hand, the same thing. And they may not agree. In fact, they do not agree here. So fail to reject the null hypothesis. We have the same decision that was made previously. Now, what I want to explain is how we calculate the confidence interval fairly nice and easy and fast. So what I want you to remember is the value of test statistic when we calculated it, and this was the formula. So I want you to hold on to the numerator, and I want you to hold on to the denominator. And make sure you have it. Why is that? Because when we want to calculate this, it's going to come handy. Number one, this t, it comes from the critical value. This is identical to the denominator here. Do I have to calculate it again? Absolutely not. I'm going to use this value. And so therefore, E be calculated in no time. Take a look. We are using the t. Remember, this was negative. Of course, we put the positive here. It doesn't matter. It's plus minus here. And what about this one? Do I have to calculate it? No. I take the denominator and I put it here. Now I have that. What about x1 bar minus x2 bar? I already have it as -3. I'm going to add and subtract this number. So what am I trying to say? Calculation of confidence interval will be extremely fast if you hold on to your numbers that you calculated for the previous step. As you can see, the numbers are between negative and positive. Because the confidence interval limits contain 0, there is not a significant difference between the two means, which gives us the same result as the test of hypothesis. Again, technology, if you remember, uses a different degrees of freedom and different results. We are looking at technology. So here's the numbers, negative 5 point, let's say 5 and negative 0.5. Both of them are negative. We do have the same result as the test of hypothesis for this one, which rejects the null hypothesis. Please understand, technology will reject the null hypothesis. The confidence interval, both values are negative, and it gives you the same result as technology did. Now we're going to do the same thing, and now we're going to assume equal variances. By the way, as I've mentioned, normally out there we don't do that, but in case I want you to be exposed to one example of that. The first part is identical, H0 and H1. The next one uses what we call the pooled variances, and it uses this formula, which is in essence the weighted average. And so you have to calculate this S sub P and put it in here. So let's do that. We go through the process, which takes a little bit of time if you're doing it by hand. So now we are ready to calculate the test statistic using this formula. And now notice I put -0 because, as I said, the formula here will have mu sub 1 minus mu sub 2. You calculate this. And again, I want you to pay attention to the numerator as well as the denominator. On purpose, I put them here. You'll see in a moment why. We end up with the following. Critical value, alpha is 0.01. Degrees of freedom, they add up. In other words, 50 minus 1, 40 minus 1, they add up to 90 minus 2, or 88. Now, again, if we are going with the table, it's limited. 88 doesn't exist. Sometimes they go down. I think it's better to go with the number closest. So 90 is fine. And again, some texts, they say always go down. So they would go to the closest number to 88 on the table, but smaller than that. Either way, the result will be very similar. And so here's what we have now. If you look at the critical value, negative 2.368, and compare it to the test statistic calculated at negative 2.4316, it puts us way into the rejection region. So we are going to reject H0. What about the rest? Let's go back here. If you're rejecting H0, you're accepting H1. That means you're accepting the claim. The claim becomes true. There is sufficient evidence to support the claim that Company A's yogurt cups contain on average less calories. Now, if we were to do the p-value, again, the degrees of freedom is 90, t is between those two numbers, and we come up with a p-value less than 0.01. Nobody expects you to do this by hand because the table is extremely limited. What I want to explain here is, if you kept up with this calculation, take a look. The numerator is x1 bar minus x2 bar. What about the denominator? Remember what E is. E is T alpha over 2 squared up SP squared over N1 plus SP squared over N sub 2. So T, we have it as this number, of course, so we don't have to look for it. What about this quantity? It's the same denominator as here, so therefore it's the same as this number. So one more time. When you look at E, is the product of a T, the critical value, you already have it. And this mess, which is the denominator of test statistic, right here. So the calculation for the confidence interval is extremely fast. You come up with the answer. As I mentioned, x1 bar minus x2 bar is the numerator. Add and subtract this number. And notice both numbers are negative. 0 is not contained, and therefore we get to the same result as here. Because the confidence interval limits do not contain 0, there is a significant difference between the two means. Reject the null hypothesis. If we were to do it with technology, those are the commands we need to use. And again, you have them in the PowerPoints.
Test a claim that weights of male college students have a larger variance than female college students. Use a significance level of 0.05 and assume the populations are normal. Alpha equals 0.05.
The given are here symbolically. There is not much we have to do. Let's start with writing the first group as n sub 1, s sub 1, and the second group as n sub 2, s sub 2. Generally speaking, when it is up to you, it is extremely important to understand when we have a choice, we choose the groups such that the one with the larger S variance or sample is the first group. Because of the restriction on F distribution, which is a right tail test. So how do we write that? I have written it here in different ways, so please do not write all of them. You have to be consistent. You write one of them, the one that they asked you. If you wrote this one, H0, sigma 1 squared equals sigma 2 squared, then it goes with this one. This goes with that one. If you wrote it this way, the second way, you can choose those two. Again, you can't write all of them. You shouldn't write all of them, but there are three different ways I wanted you to be exposed to. Here's the third one. Please do not use all of it. I'm just showing you. You can say sigma 1 squared equals sigma 2 squared. Sigma 1 squared is larger than sigma 2 squared. That's done. Perfect. You're fine. Or sigma 1 squared, the ratio of sigma 1 squared and sigma 2 squared is 1, otherwise is larger than 1. Or you can say sigma 1 is equal to sigma 2. If you go with that, sigma 1 is larger than sigma 2. And H1 happened to be the claim, and it is a right tail test. So with that being the case, test statistic, it can't get any easier than that, can be calculated as S1 squared over S2 squared. Critical value comes from the choice of alpha. Degrees of freedom of a numerator, the first group, n1 minus 1. And the second group, degrees of freedom of the denominator, n2 minus 1. So when you look at the table, the very first thing you must look for, alpha of 0.05. That's the first thing, because F distribution has many tables with different alphas. Then degrees of freedom of the numerator here, top row, and the denominator is the left column. You put them together, and you see that it's hard to read it here. I didn't have enough space. You can look up the table. We end up with 1.8687. Let's do the drawing to make a decision. Alpha of 0.05, critical value of 1.8687. Let's put the test statistic in there, and it's way into the non-rejection region. So fail to reject the null hypothesis. So let's stick with the first one. Don't reject the null hypothesis. So if you're not rejecting H0, that means you're rejecting H1. So you're rejecting the claim, and the claim becomes false. There's not sufficient evidence to support the claim that weights of male college students have a larger variance than female college students. If you were to use the technology, two sample F test, you continue on that thoughts, and it results in the following. Notice test statistic was calculated here. The p-value, and that's very limited when it comes to looking up the table, the p-value should be found through technology. 0.27, it's way larger than alpha of 0.05, way larger than alpha of 0.05, so fail to reject the null hypothesis.
Directional asymmetry, DA, is a phenomenon whereby in a population, one side of each organism is consistently larger than the other, i.e., left larger than right. An evolutionary biologist studying DA measures the length of the left and right wings of a sample of Drosophila, a type of flies whose members are often called small fruit flies, collected from nature, and she gets these data. A. The researcher decides to perform a two-sample t-test to determine whether the mean wing differs between the left and right side of these flies. What type of t-test will she do? Alpha equals 0.05.
We are using the paired t-test because it's a dependent paired t-test. We have the left and the right side. And with that being the case, we need to calculate the difference between the two and their average and their standard deviations. So this is the good old X bar. Now we call it D bar because D stands for the difference. This is the good old sample variance. If you recall, it was summation of X minus X bar quantity squared over N minus 1. That was S squared. And we took the square root. So if you look at the difference between the two, you can actually do the one sample t-test. So you calculate the difference. For the first one is 1.34 minus 1.26 is 0.08. For the second one, 1 minus 1.28 is negative 0.28, and you go all the way to the end. All you have to do deal with this data, nothing else. If you run the information on this data and do the t-test on that, you get absolutely the same result. So the reason we use D bar instead of X bar, because D refers to the difference. Sometimes we use lowercase d, sometimes we use capital D, depending on the text. I'm using both of them on purpose because I want you to be exposed to that. Now, if we were to do this, to get the mean standard deviation 5-number summary, we know how to do that. Put the information in, run it, and it gives you D bar or X bar, S sub D or simply S. And of course, there were 17 pieces of data. I can't emphasize this enough. You just run the data on the difference between the two. Now, when you go with the TI calculator, you clear this list L sub 1 and L sub 2. So you put in L sub 1, you put in L sub 2, and you're interested in finding L sub 1 minus L sub 2. Many times we store that in L sub 3. You don't have to, but if you store it in L sub 3, then over here you use L sub 3 to do the math. Every part of the question you can do. Other than that, it becomes really the same thing for the t-test. Having said that, take a look at the concept. We are looking at the paired t-test. We found the D bar, you can call it X bar, S sub D or simply S, N. Remember the T was X bar minus mu over S over square root of N. Now, instead of X bar, I'm going to write that because I want you to remember we did recall T was X bar minus mu over S over square root of N. So you could see that it's identical to the t-test for one sample. But that gives you absolutely the same result. Having said that, let us continue. H0 mu sub t is 0, H1 mu sub d is not 0. That is the claim, makes it a two-tailed test. Test statistic using either formula, as long as you understand what you're doing. Plug in, you've calculated what you need here, plug in. And by the way, this always comes from H sub 0, and it's always 0 for us. That's why sometimes we don't even bother to write that. And again, D capital or lowercase makes no difference. Having said that, we end up with test statistic being negative 1.636. Critical value, choice of alpha is 0.05. Degrees of freedom, N minus 1 gives us 16. And from the T distribution, we get those values. We go with the graph. The critical values, negative here, positive here, and the test statistic is way into the non-rejection region between the two values. And therefore, we do not reject H0 or fail to reject H0. So stick with the first one and go back to the first step. If you are not rejecting H0, you're rejecting H1, you're rejecting the claim becomes false, and now you do the writing. There is not sufficient evidence to support the claim that the mean wing differs between the left and right side of these flights. She cannot conclude that this population possesses DA because the mean length of the wings on the left and right sides do not differ significantly. So this is statistics at work. We can do the matched pair t-test to come up with the answer. Now we want to come up with confidence interval, 95% confidence interval, D bar, S sub T, and we have it from the previous page. We have the critical value, 95% confidence interval. This is from the previous page. And so we can move on, remember, so we use the same information. E is T alpha over 2, which is the same T. E is T alpha over 2, S over square root of N, so 2.120, and we have S sub T over square root of 17. We do the math, we calculate, we finish the job. We end up with 0.1174. We have the D bar. We are going to subtract this from it, and we're going to add to it. Just like X bar plus minus E, this is D bar plus minus E. That gives us the values between a negative and a positive, negative 0.208 and positive 2.68. Since 0 is contained in the interval, the decision is not to reject the null hypothesis. In other words, H sub 0, mu sub D equal to 0. That gives us the same result as before. TI calculator, of course, can be used as well.
An ecologist is concerned with whether pollution entering part of a preserve area is compromising the health and growth of an endangered species of snake. To determine this, he decides to measure the length of a set of mature adults from the polluted area and an unpolluted area. The researcher decides to perform a two-sample t-test to determine whether the mean length of these snakes differs between these two areas. Alpha equals 0.05.
We collect data from the two areas, and now we need to do some calculations for each part. So we have the sample size for the first group is 15, for the second group is 17. Now we need to calculate the standard deviation, the mean, and as I said, the sample size clearly is 15 here, it's 17 here. So you run the data, and it results in the following. Again, this is not done by hand, this is by technology. But even if you do this part by technology and the rest by hand, at least it's important to understand the steps. So having said that, the first step, H0, mu sub 1 is equal to mu sub 2. H1 mu sub 1 is not equal to mu sub 2. That is the claim, that's a two-tailed test. So the two groups, they have different means. That's the idea behind this. So calculate the test statistic, plug in all the information. It results in 2.8022. So everything that we have calculated here, we put it into this formula, T equals x1 bar minus x2 bar over the square root of s1 squared over n1 plus s2 squared over n sub 2. If we were to do it by smaller of the two, n sub 1 minus 1 is 15 minus 1 or 14. And this t will give us plus minus 2.145. Let's do the drawing. So we have negative and positive, and this number 2.8022, it's even larger than the positive value. It's way into the rejection region. Therefore, you're going to reject H0. So going back to the first step, if you're rejecting H0, then you're accepting H1, you're accepting the claim, and the claim becomes true. The claim is true. There is enough evidence to support the claim that the mean length of these snakes differ in these areas. It is larger in the unpolluted areas since test statistic is positive. By the way, it also gives you this information because this is positive, that means it is larger in that area. So having said that, if we go with the calculated result, remember what I told you, Degrees of freedom is calculated using this formula. And 29.38, we choose 29. We always round down. And if we go with technology that happened to give us the same result, the p-value ends up being less than alpha of 0.05. P-value is 0.009. We get the same result, which means reject H0. But pay attention to the fact that the degrees of freedom here is calculated at 29.38. We choose 29. Over here is 15 minus 1 or 14, yet they give us the same result.